Hello everyone, welcome back to my YouTube channel. This lecture is on binder jetting type of 3D printing technique. This is in continuation of last lecture, that is inkjet printing, which is linked above in the top right corner. So, in contrast to inkjet printing or material jetting, wherein the part material was directly dispensed from the print head, here part material was directly dispensed from the printhead. Binder jetting technique prints a binder into the powder bed. Okay, so it doesn't dispenses a powder, instead it dispenses a binder material onto the powder bed. So this binder material then helps the powder particles to stick together or consolidate to form one solid object. So the key difference lies in between inkjet printing and binder jetting lies that what is being dispensed from the print head. In inkjet it is the part material, whereas in binder jetting it is the binder. Okay. So this was first developed in early 1990s at MIT and was more commonly called as 3D printing. Okay. Let us move forward to the basic schematic of a binder jetting technique. Here, the different parts are the XY positioning system, the Z-axis movement, inkjet printhead, binder jetting printhead, binder droplets, unused powder, build platform, and this dark hut-like structure is the part and a powder spreader. So this XY positioning system helps in the X and Y movement of the printhead. This binder jetting printhead has has the binder and it allows for dispensing the binder droplets through its nozzle. Now Z-axis movement allows for raising and lowering the platform as and when required, or whenever one layer is cured and then a new layer is to be set up, then this Z movement is required to lower down the platform. Last is this powder spreader that is based on counter rotating rolling mechanism. This counter rotating rolling mechanism. So here there is a tank that contains the powder. That tank is lifted upwards and this powder spreader carries away a layer, some amount of powder, and during rotating ultimately it uniformly deposits this layer on the printer bed. That there is uniform deposition of constant layer thickness. Okay. Now let us look at the steps that are to be followed during binder jetting kind of 3D printing. First, a layer of powder. A layer of powder that may be plaster or ceramic or any other material that you are printing is spread across the build platform. Now, secondly, part is built when this print head dispenses some adhesive material onto this layer of powder. That adhesive material is what we are referring to as binder. Part is built using binder jetting printhead to eject out adhesive bonding material or binder onto the layer of powder. Okay. Now, next is where this binder should be deposited. There should be some guiding mechanism where as to where this binder is to fall and deposit. So, binder is deposited in areas corresponding to the cross sections of the part. Now, one may ask, from where does this information of cross section of the parts come from? This comes from the CAD model that we supply, and as that CAD is sliced and supplied to the 3D printer, it can give layer wise information. Okay, as was told in the steps to be followed for general 3D printing. Okay, the video is linked above. You can check that out in case you haven't checked. Determination by sliced CAD geometry into layers. Okay. Now next is, what does this binder do? This binder holds the powder particles together. Okay, holds the powder particles together to form what? A solid object. Whereas the unbonded particles remain loose. And they can be removed later on. These loose particles, they also act as support for the overhang parts in the structure. Okay. Next, when these binder droplets have been dispensed, they have solidified the required powder on the build platform and certain unused powder is left loose. Now what? Then the platform is to be lowered. The build platform is lowered. Okay, and a next layer of dry powder is spread across it. Using what? A counter rotating rolling mechanism. Okay, so this process is repeated until the final object is obtained. This 5-step process discussed above is repeated until complete object is manufactured. Then, when the complete object is manufactured, the part is extracted from the build platform and the remaining loose or dry powder is brushed off. Okay, this powder can then be recycled using certain criteria. Okay, let us discuss certain specific features of 3D printing. As discussed, only small amount of binder material is dispensed through the print head, whereas most of the part material is comprised of powder in the powder bed. Now, these binder droplets are approximately 80 micrometer in dia, okay, and they form spherical agglomerates of binder liquid and powder particles to provide bonding. So, they form spherical agglomerates of binder liquid and powder particles so that it can effectively bond the different powder particles and the previously printed layer. The powder is glued together wherever the binder is deposited, whereas the remaining one remains loose. Because of the slow and accurate build style as well as the waxy materials, these machines are often used to fabricate investment castings for the jewelry and dentistry. So they are used for investment casting manufacturing owing to the complexities that it can handle, owing to the precision and the smallest size that it can handle. Okay. Now a typical nozzle will deliver approximately about 1 centimeter cubic binder per minute. This is the usual flow rate that is observed. So as we increase the number of nozzles, we can effectively increase the print rate, and hence the speed of the process can be enhanced. Because there are commercial printers that exist with up to as much as 1600 nozzles that function together in a single go. So this technique can be fast enough that it can be used for mass production. Okay. Now another advantage one is that combination of powder and additives in binders allows us certain material compositions that are actually not possible otherwise. Okay. Using what? Powder plus binder. Okay. So we have better quality prints using binder jetting. Now let us have an overview of the materials that are used in binder jetting 3D printing. We have firstly the polymeric powders that can be effectively used. One of the main polymeric powder is PMMA, that is polymethyl metaacrylate. This is used in combination with a wax binder. Okay. Next we can go with metal powders having polymeric binders. Okay. So polymers are used as binders in this. So for metals we can use stainless steel with bronze as an infiltrant. Infiltrant are used to add like enhance the density of the final part and the strength, along with a polymer as a binder material. Another metal that we can use is inconel powder or titanium powder as well is used. Next is ceramic powder. Ceramics are difficult to process using conventional techniques, but 3D printing allows us to process ceramics with a bit ease, as here we can use ceramic powders along with inorganic binders. So it allows us to make ceramic components of high quality and high solid loadings. So alumina, silica, titanium dioxide and silica sand, they have been successfully printed using binder jet 3D printing. Let us have a look at the process benefits and drawbacks. So major advantages are it prints much faster because only a small volume of material is to be printed. Also, multiple nozzles can be employed to function together to further enhance the speed. Okay. Next is we have unique material combinations and composite formations, as we have seen using different combinations of binders and powder particles. We can have slurries with much higher solid loadings, thereby giving us much denser parts or much pure parts. Okay, then it does not involve any kind of lasers or toxic materials, does not involve any laser slash toxic materials. Okay, and it is a low cost and low energy process. It is a low cost and low energy process. But we have disadvantages are that it has poorer accuracy and poorer surface finish in comparison to inkjet. Okay, and obviously materials are limited to some extent, although we can have a wide range of combinations, but to some extent materials are also limited. Okay, so this was all for binder jetting. Hope you understood the things clearly. Thank you.